linear equation solving, a review. So it says the expectation of the Common Core is that students have mastered all types of linear equations in 8th grade Common Core math. Well, you guys did that in 7th grade math because you were in 7 accelerated. So let's take and do some review here. So we've got some two-step linear equations, and let's keep in mind about reversing the operations that had occurred to the variable, because that's exactly what we do, is we reverse our operations. So I'm going to highlight, whoops, thought I had my highlighter on. I'm going to highlight that. Okay, reversing the operations that had occurred to the variable. So what do we mean by reversing our operations? So what's the opposite of, or I should say, the inverse of addition? Okay, we think subtraction and vice versa, or multiplication, we think division, okay? Or division, we think multiplication. So, looking at letter A, I've got x divided by 3 plus 7, or excuse me, minus 7 equals negative 2. So I would start, and I would know that I would have to add 7 to both sides first. X divided by 3 equals 5. And now if I've got x divided by 3, what's the inverse of dividing? We've got to multiply by that 3. We are left with x is equal to 15. Letter B, again, another one pretty simple. I would subtract 3 from both sides first. Negative 20. 4 times x, so I've got to divide by 4. X is negative 5. Now, we know that we could take what we found for x and substitute it back into the original equation to see that our solution is true. So I'm going to work through some of the other ones, some of the more difficult ones, and I'm going to show you how to check it on the calculator, which ends up pretty cool. I'm just going to give you the answer to C. That one is 15. By all means, work it out if you'd like. Let's look at D. So D's got x plus 7 divided by 3 equals 2. So if I'm dividing all of that by 3, I'm going to multiply both sides by 3 so I can undo that. I'm going to have to sneak that 3 in there. Those are going to divide out. So we've got x plus 7 equals 6. Now we get a one-step equation. And x is equal to negative 1. Pretty cool. All right, letter E. We've got some parentheses, and we've got to distribute. So negative 6 times x, negative 6x. Negative 6 times negative 1 is a positive 6. Be careful of your negatives. Whoops, I don't know why my highlighter just decided to turn on. Let's go back. Equals 18. Subtract 6. Negative 6 equals positive 12. Got to divide because that negative 6 is being multiplied by x. So to undo that, and I end up with x is negative 2. All right, the answer to F is negative 1/2. Again, I'm not going to do that one, but by all means, do so. Letter G, x is equal to 12. We're going to do letter H together. So negative 5/2 x plus 6 equals 1. I've got to subtract that 6 first. I've got to try to move everything away from that variable first. So negative 5/2 times x. Sometimes if you say that to yourself, it helps you to determine what your opposite operation is going to be. Equals negative 5. So if it's negative 5/2 times x, we could divide by negative 5/2 on both sides. That absolutely is mathematically correct. Or you guys are used to multiplying, when you have a fraction like that, multiply both sides by the reciprocal. So we flip that negative 5/2 over and make it negative 2/5. So if I multiply one side by negative 2/5, I absolutely must do that to the other side. Those end up okay? Dividing out to 1. We're left with 1x. And then negative 5 times negative 2/5 gives you positive 2. So let's go to the calculator on this and let's check our solution. So we know negative 5/2. What do you do with your solution? You plug it back into the original. 2 plus 6 supposedly equals 1. I'm going to put, I can change the color. There we go. I'm going to put a question mark above there because I don't know if it does equal that. So when I go to my calculator, I'm going to type in exactly what I just substituted. So fraction, negative 5/2 times negative 2. I'll make sure I'm not in the denominator anymore. There we go. Times negative 2 plus 6. Does it equal, use a regular equal sign, does it equal 1? See? False. Uh-oh. What did I do? Negative 6 times, oh, I know what I did. I put in a negative 2 and it's a positive 2. So I'm just going to go back. I'm going to arrow up and I'm going to highlight it. I'm going to cut and paste it. And then I'm going to go back in and edit. It actually worked out quite well. I made a mistake. Shows you that if it's wrong, it gives you a false answer. I didn't do that on purpose. There we go. We got a true answer. Okay, so you can check any equation like that. Solve it, get your answer, plug it back into the original, and see if you get true. If you get true, you've got it right. If it's false, you did something wrong. All right, and letter I, I'm going to give you the answer for that one as well. X equals negative 2/3. All right, go ahead, flip the page. All right, it says, for most of what we do the rest of the way, you'll be using the distributive property as well as others to solve problems. Don't forget your primary technique of solving by reversing operations. Okay, that's a biggie in our solving. Okay, but we do use the distributive quite a bit. It says, solve the following equation for x by identifying the operations that have been done to x and reversing them. I think we're going to pass by that one, because we know what's going on when we reverse things. Let's actually do one. Okay, so we've got our equation, 5 times the quantity of x minus 3 plus 2x equals 4 times x plus 3. By using the distributive property, write equivalent expressions for both sides of the equation to show your work below. So when I use the distributive property here, I'm going to do 5 times x and 5 times negative 3, which turns to 5x minus 15 plus 2x equals 4x plus 12. All right, so when I combine like terms, 7x minus 15 equals 4x plus 12. By using the distributive property and combining like terms, we've got these two expressions that are equal to each other. Now part B says solve for x. So we're just going to continue on with this equation and get x by itself. So we've got our variable on both sides of the equation. I'm going to choose, this is just my preference, I'm going to choose to subtract 4x from both sides. 3x, and I'm going to add 15 to both sides, equals 27. Divide by 3, and x equals 9. Now it says check to make sure the original equation has a true value for the x you find. So we found x to be 9. So we always have to, whatever you solve for, always has to go into the original problem. So when I go to back to my calculator, I got x is 9 So I'm going to say, I'm just going to find my equation. 5 times, and was 9 minus 3. Then we got to go outside the parentheses, plus 2 times 9 equals, does it equal? We're kind of questioning this right now. 4 times 9 plus 3. Enter. True. Got it right. Okay. Always check your equations. Okay. You've got the calculator that can do that for you so quickly. So what do you need to show me, the teacher, the corrector, that you did a check? Because so much of it is done on the calculator. So for a check, what I need to see, I need to see that substitution into the original equation, exactly what you are typing into the equation. So this is the work you would show me, the corrector, okay, that you did your check, and then hopefully you got true. Okay, so what I just wrote in red is what you would need to show when it says check. Okay, so let's look at this next example here. Wow, got lots of parentheses, but we know how to handle those because we can use the distributive property. 7x minus 14. This one we've got to distribute a negative 3, so be real careful. Negative 3x minus 9 equals, got to distribute on the right-hand side here, 5x minus 15. But we're not distributing to that x because that's not in the parentheses, so that's just a plus x there. A lot of combining of like terms to be done. 4x minus 23 equals 6x minus 15. So we've cleaned that up. Again, I think I might choose to subtract 4x from both sides. Minus 23 equals 2x minus 15. Add 15. Oops. Move that again. There we go. So negative 23 plus 15 is negative 8 equals 2x. Divide by 2. X equals negative 4. Okay? Check that on your calculator. I'm not going to do that because that'll take up a little bit too much time right now. But take your negative 4 and always go back to your original. Substitute it in wherever you see an X, just exactly the way you see this, and you should get a true. Okay? Letter D, another good one to work through, but I'm going to give you the answer for the sake of time. X is negative 2. Okay? Let's go ahead to the next lesson, which is justifying the steps. And we've done some of this, which is pretty cool already. So let's scroll past this. And there we go. So we've done these before when we were dealing with our properties. Okay, so it says up here, let's see if I can get my highlighter back out again. Let's change colors. There we go. Generally, we justify the steps we take in solving linear equations using commutative, associative, and distributive properties. Okay, that's what we practiced in Unit 1. We're going to throw 2 more properties into the mix, and these are your properties of equality. You've been using these all along since you started solving equations. You just may not have known that there was an actual term for it. So the additive property of equality means that you can add something to both sides of the equation, or you can add a negative to both sides of the equation, and it still retains the equality. So it doesn't change the value. That's why whatever you do to one side, you have to do to the other. So it says you can add or subtract the same quantity from both sides to retain the equality. That's what you've been doing all along. Then the multiplicative property of equality means that you could multiply or divide something on both sides of your equation, and it still retains the equality. Okay? So real basic, they give us a two-step equation here. It says what would be the steps justifying each step. So here's our initial equation. So what did they do from the initial down to here? So 2x plus 9 equals 21. Think what you would do in your head first. You would subtract 9 from both sides. Well, that's exactly what they did. Subtracted 9. So what property tells us we can do that? And that's our one of our new properties, our additive property of equality. Then to finish that off, those would end up, that would end up 21 minus 9 gives you 12. Then you'd have to finish that off. We'd have to divide by 2. Well, they multiplied by 1/2. That's the same thing. Dividing by 2 or multiplying by 1/2. What allows us to multiply both sides by 1/2? And there's our second new property, the multiplicative property of equality. Okay. So let's jump to something a little bit bigger. So we've got this equation here. Okay, here's our original. So what was the first step? Just even before you look down here, what would you do? What do you think your first step would be? And you'd probably say the distributive property. Well, that's exactly what they did. So you can see 3x plus 6, and then they distributed that -2. So there's our distributive property. And then what did they do? How did they go from step 1 to step 2? So I kind of examine and I see that these two have been switched around. Okay, when you switch things around, that's the commutative property. Okay, again from last unit. Then what happened? So we've got this from 2 to 3, and now all of a sudden we had 3x plus a -2x plus 6 plus a -14. Okay, what changed from here to there? So they each contained an x, and now all of a sudden that x is out in front. So if we redistributed, x times 3 would give us 3x, x times -2 would give us -2x. So what happened? They undistributed, so essentially they just used the distributive property. It's deceiving. You want to say that it's associative because you see parentheses, but they didn't change the groups. Okay, they factored out that x, so that's just the distributive property. Then what happened? And I'm looking, okay, so they cleaned some things up here, and now we've got, it's this right here, and now all of a sudden it looks like they subtracted 4x from both sides, and then they added 8 to both sides. So that's our additive property of equality. And examining it again, we've got some shifting going on. We have x minus 4x where we had a -8 in between, so they shifted some things around. There's our commutative property. And then we've got that x outside. Okay, what was common to those two terms, now it's outside. That's the distributive property again. Undistributed there. And then we've got -3x equals 15. What would you do? You would divide by -3. So that is, we divide by -3, or we'd multiply by you would divide by -3, or you'd multiply by -1/3. So that's our multiplicative property of equality. Okay, go ahead and flip it over. So this one is filled in. Okay, some of them are filled in for us. I'm going to fill this in for you. Not that I wouldn't any other time. I'm just going to kind of buzz through it a little bit. So, because I want to get down to the bottom, because the bottom is the big thing with this equation. So this is our distributive property. By all means, pause it and then check it to see if you can fill these three in. So there's our commutative property. But look what happens here. This is what I wanted to get to. Wow. All of a sudden, what happened to the variables? 2x minus 2x. They wipe each other out. We got negative 11 equals 0. Is that ever true? Okay. Is that statement true? No way. Could any value of x make this statement true? Okay. It's not possible. So what do we know about the solution to this equation? Okay, what makes this strange? Okay. The value of x that make it true. Okay, will anything make it true? Nothing. Will make it true. So if that's the case, do we have a solution? Absolutely not. No solution to this one. I think you guys are pretty familiar with this. Okay. And now we've got this last one. And this one is another one of those sort of cool cases. They've given us an equation here, and they say show that x equals negative 5 and x equals 2 are both solutions to this equation. So what do we do to show something's a solution? We substitute it in, and then we go to our calculator. 9 times negative 5 plus 10. Okay? So I'd go to my calculator, type this in exactly the way we see it, and hit enter, and you should get true. And then I would go in, I'm going to try and shrink this, see if I can squeeze, oh, look at that magic. Alright, I'm going to try this next one, I'm going to try 2. So, substitute that 2 in. Go to my calculator, type it in exactly the way you see it, hit enter, and we get true again. Holy smokes. We get 2 answers that are true. It says, solve this equation by manipulating each side. Okay, so, whoops, just flip that around. So here's my equation. I would distribute, and then I would combine like terms. What do we got going on here? 9x plus 10 equals 9x plus 10. You guys saw this on your weekly, maybe last week. When the left side equals the right side like that, what do we know? Okay, what do we know about the values of x? Okay, you guys knew there are infinite solutions that would make this true. You could pick any value of x to make it true. So pick a random integer, okay? Or really any number. I'm going to go with my fave, x equals 1. And putting that into, let's see if I can see my original. And we'll be done. Can I see the original? Where'd it go? There it is. Okay. 7 times 1 plus 2 times 1 plus 5. We can move my recorder out of the way. Equals 9 times 1 plus 10. Again, go right to your calculator, okay, and see, we end up with, let's see, we got 7 and 12, that's 19. 9 times 1 plus 10, 19. Winner, winner, chicken dinner. All right, my friends, we are B-O-N-E.